Good afternoon and welcome to Lecture 2. Today we will talk about consumer choice and demand. This will be our first lesson in a series of lectures that we will talk about market structure. So in order to analyze the market, we need the demand, we need the supply, and today we will start from the demand side. So let's remember what we said in the previous lecture. So we started with a course presentation. We presented the course and how everything is going to be with respect to policies and with respect to your expectations. We defined economics. We said what economics is and what economics is not. And then we talked about the differences between microeconomics and macroeconomics. And we said that in some cases the difference is a little bit difficult to see, but it's always there. Then we talked about opportunity cost. We talked about accounting profit versus the economic profit. And then we talked about two philosophical principles that we use in economics a lot. The first is the ceteris paribus principle, and the second one is the post hoc propter ergo hoc fallacy. And finally, we had a tutorial video that we explained what happens with graphs and equations. I hope you followed it and you found that it was quite helpful, even though you knew some of the terms, just to refresh you what is going on with the level of technicalities that we will use in this class. So I want to start today's lecture with a question that we have to ask ourselves, and we have to search for an answer before we know what is going on. This question is a very simple question. What is the single characteristic that determines if something, anything that might be, will have value? What is this single characteristic of something that determines if this something will have value, high value, low value, or not? In other way, the best proxy that we have to measure value today is the price of something. What is this single characteristic that if a good or service or anything has it, then it's going to have a high value or price, and if it doesn't have it, it's going to have a low value or low price. So pause the video here and go down below in the comments and write your answer. It should be 1 or 2 words, just a single thing, not more than one. Just the one thing that is the key value, like the key characteristic that if you have it, then high value. If you don't have it, or if you have less of it, low value. So pause the video, write it down below, and we will continue from there. In this case, the question that we ask is, what is the single one thing that determines if something or anything will have value? And some of you, I'm sure, I'm teaching this class not for the first time, so I'm sure that you wrote that the number one characteristic is scarcity. So the less you have of something, the more valuable that would be. This is partially true, but you can find several counterexamples that this is not true at all. Like, for example, you can have some quite rare things that they are totally valueless. All right. Like, for example, I can make a drawing for you. I have amazing drawing skills. I can draw something for you, and then you can buy this because this is going to be unique. And since this will be my one and only painting that I will do, you should give me perhaps a few billions of dollars for this? I don't think so. Okay, so we see that even if something is quite rare, this doesn't guarantee value of this thing. You might think of many other different examples of something that is, for example, very, very useful. So utility, how much useful is something to you? The more something is necessary, the higher the value of this thing. Again, there are many examples of things that they are super necessary in our lives, but they are not valuable at all. Okay, for example, the most necessary thing for life oxygen is totally free. It has a value that is super, super low. At least the price is super low. Last time I remember 10 seconds ago that I took a breath, I didn't have to pay anybody anything for it. All right, so we can see that scarcity alone or usefulness alone by itself, it doesn't really determine value. So what is the answer to this question? The answer is that there is no answer. And it took people almost hundreds of years, philosophers, to come up with a process of thinking that will understand what determines value. This was actually the core question for economics when economics started being developed as a science in ancient Greece. Aristotle put up the word economics, and he actually started to study what are the laws that households follow in order to maximize their utility and in order to maximize profit from what they are selling. And one of the key questions that he was asking is what determines value? So nobody could come up with one single thing. So we automatically went to the second best answer to this question, which is two different things. Two different groups of things, actually. One group is the demand, and the other group of things is the supply. So we split those factors in two different groups. One is the demand, the other is the supply. So for example, how useful or necessary something belongs on the demand side of things. How scarce is something depends on the supply side of things. So we can see that we have two different groups, that the demand and the supply, and those two different groups interact with each other and determine the price, or in other words, the value in the market that something has. So one of the basic issues that economics addresses is what we refer to as the economic problem. The economic problem has to do with scarcity. Human needs are unlimited, but resources are limited. Okay, so resources are not unlimited, and therefore we have to make sacrifices. We have to make choices. In a world that resources would be totally unlimited, the only choice that we would have to make every morning would be like, should I wear my golden Rolex or my platinum Rolex? And should I get my yellow Ferrari or my black Lamborghini? Anything goes. Like, the only choices you have to make is choosing what you're going to use that particular day. Okay, but because we cannot do that, and last time I checked, I didn't have 3-4 different Ferraris to select from, so this leads us to make choices. Once you make choices, the best way to do that is with one way of thinking that is being known as the economic way of thinking. And this is exactly the core of economics. Economics is not so much a science, is not so much a practice, it's something much more than those two. Economics is a way of thinking. And that is why it ends up being a core course in the education of students almost everywhere in the world. So given that resources are scarce, complex societies, they have to go and answer some basic economic questions. What are these questions? First of all, what gets produced? Who decides if we will produce one thing or if we will produce another one? We cannot produce everything. So for example, who decides that we are going to stop research on heart disease right now and we're going to intensify research on COVID-19 vaccine? So who makes this decision? According to whose preferences and to whose thinking this decision is made? So what maximizes, in other words, people's utility, people's satisfaction from the society, and what maximizes firms' profits? The second question is, how is it produced? Often there are different methods of producing something. Like, for example, you can produce a pair of shoes totally handmade, or you can produce them totally machine-made. Who decides about the method of production? Who is the one who will come up with a decision about how this particular production will be done? Are we going to focus more on labor, or we're going to focus more in capital, in machines? And how is this exactly going to be produced? Are we going to produce it here, or are we going to outsource it? So methods of production is one part of this key economic problem. The number 3 question that we have to ask, one of the most important ones, is who says who is going to consume what? Who decides, for example, that some people will go to work with a bicycle and some other people, they will be driven in an Aston Martin by a driver and will have like 4 security cars around them? So who decides that one person goes in this manner at work and the other goes in the other manner? Who decides that somebody will wear Gucci and somebody will wear the same clothes for a week? We have to search, we have to study who makes this decision, how we end up making this decision. In every society in this world, we end up making such decisions. All these questions will be answered in all forms of organization, from the very, very ancient times that people were not that much different than the other animals in the animal kingdom, up to today that we have a civilization that is capable of doing amazing things, bad things also, but also amazing things. All right, so all these 3 questions are answered. Now, the best way to approach these questions is to approach it as a system. So societies are organized in a systematic way. They are not organized, they're not answering independent questions, individual questions. They answer everything with an entire system. So societies adapt systems to solve the 3 basic questions of the economic problem. We have one system, which is a command economy system, meaning that you have somebody or a commission, usually some particular person, and this person is the one who makes particular decisions with discretion, directly or indirectly, sets the output targets, how much is going to produce, of what is going to be produced, how is it going to be produced. It sets the incomes of everybody. So for example, you are going to make that much, you're going to make this much. All right, and finally, who consumes what and at what prices products or services will be transacted, if there will ever be transactions in this particular command economy. So in the command economy, somebody just commands, bosses people around, tells them what to do. Sometimes this person can be like the smartest person of all of them, and these decisions will be totally benevolent and everything will work totally fine. Some other times this person might be a not very sane person and may create, for example, a world war or something like that. All right, so we have this particular system. Another totally opposite system is the laissez-faire system. That's a French term, means everything free. Means that it's a totally libertarian way of organizing everything. There is no government. What drives the economy and the society is the self-interest. So this is based on the fact that if I do the best for myself, and you do the best for yourself, and everybody is doing the best for themselves, then we are all together doing the best for the society also. So this is this kind of premise that is behind this ideology. Now, to be honest, there is scientific evidence that this doesn't work. At least doesn't work if you let it entirely free. Okay, so if you enter an economy that will be like a jungle kind of economy, you will see that some of the players in this particular economy, because of random factors or because of other traits, they will become extremely big, and they will start governing the whole economy. Will start from a laissez-faire situation and will end up to be a command economy, because you will have like a couple of monopolies governing everything in the end. So what we usually observe is something in the middle, a mixed system. And this is pretty much what we have in the entire world. And there are a few exceptions, like, for example, there is North Korea, where they are towards the command economy, very, very close to being a real command economy. Then you have Cuba. We used to have a Soviet Union a few decades ago. This didn't go very well. We used to have China, which is also now is transformed to a clearly mixed system. We do not have any good examples right now about laissez-faire economies. There are no real examples about a country I can name that is everything is totally free there. There is no government. Everything works by itself in a nice way. This doesn't exist. There are mixed economies. Now, the economies can be mixed in different proportions. Like, some economies are a little bit more paternalistic than others. Even in this case, though, it will be extremely difficult to put an index, to put a number to how close. Like, for example, if you say that 0 is going to be the command economy and 1 is going to be a laissez-faire economy. Okay, 0 and 1. And we want to assign a number, a fraction between 0 and 1 to what type of economy, for example, Belgium is. Okay, we cannot assign just a single number like that. And let me give you an example why we cannot do it. There are some things that they are free to do in the United States, but you cannot do them in Singapore. There are much more things that you can do in Singapore that you cannot do them in the United States. And for example, you can do both of these things that you cannot do in Singapore and United States. Maybe you can do them in France. Okay, so you don't have like a scale of freedom or totally command economy that you can rank the economies between there. So for example, in Singapore is one of the most free economies in some extent, but in other extent it's very heavily regulated in some other things. All right, so we are always in the middle, but different economies, they select a very different mixture of different things, of different decisions that they make in order to organize and give answers to these three particular questions that we saw before. So after this short introduction, let's get started to talk about what we will see today. So today we'll talk about the budget, the necessary resources that we have in order to start spending and demand things. Then we will talk about the reason why we demand things, which is utility. And then we will talk about demand as a function, as a relationship. We'll talk about the very important characteristic of elasticity of demand. And then we will end today's discussion, today's lecture, with the cross-price elasticity and the income elasticity. All right, let's get started with the budget. I have selected this young lady here that is not entirely sure if this is orange juice or not, so she has to check it. So we will understand how more important decisions than if this is an orange juice or not are made in general. All right, so consumer decision. How do consumers make their decisions? So how consumers decide what to buy and what to not buy? There are three parts that they give you the answer in that. The first is you buy the goods and services you like or need. Sometimes I buy things that I like and I don't really need, and I kind of realize it way afterwards I have bought them. Or sometimes you know that something you don't need it, but you still like it. Sometimes you even like the process of buying things and you just buy them. We live in this kind of first world right now that we can buy things that we don't even need just because we like the process of buying them. But sometimes you buy things that you need and you don't like. I remember, for example, when I first moved in Singapore almost a year ago, I moved here, I just had my suitcases, nothing else, my clothes. And when you move to a new place, you just start remembering all these things that you have to buy. Usually you buy them, normal people that they never move to another country, they buy them once in their life and then they totally forget about that, or even they find them at home and then they keep having them. One of those things is an ironing board. Okay, so an ironing board is something that you have to buy once you move into a new place, because if you want your clothes to be ironed, that's something that you need. So when I bought an ironing board, I was not an enthusiast of ironing boards, like some other people are enthusiasts of snowboards, for example. I bought it just because I needed it. I wanted not to enjoy having an ironing board, I wanted to enjoy that I had an ironed shirt afterwards, and this made a difference for me. So you buy either things that you like or need or both, and these are the things that they maximize your satisfaction. So maximize the pleasure that comes out either from this particular thing that you bought, or enjoying the particular service, or enjoying the aftermath, the results of this service. Like, for example, I don't think that anybody enjoys taking their medication when they are sick. You take the antibiotics not because you enjoy taking antibiotics. Never met anybody who likes to get high on antibiotics, actually. But you take them because you enjoy the fact of later being healthy from taking this medication. So you enjoy the aftermath of your consumption of this particular thing. So consumers are assumed to try to maximize the utility. They want to get as maximum pleasure or satisfaction as possible for their buck. So they receive this from every product that they choose to buy. So they choose those products that they, by liking them or needing them, they will maximize the utility out of the purchase. The prices of those goods or services is also important, because there are many things that I like and I do need, but unfortunately I cannot buy them. Like, for example, believe me, I do need my own private jet, because it will be very necessary for me every Friday evening to take it. I guess I will have a pilot also. What the heck? Let's put a pilot. I will have my own personal pilot, and I will be like, take me to Athens. And I will go spend my weekend in Athens, and then on Monday, I will be back here. Believe me, I desperately need that. I will enjoy it. I like it. I need it. It will give me tons of utility. The only problem is that the price is too high. And not only that the price is too high, the other thing that doesn't help is that my income or wealth is not enough. Because even though you can find some of those in really quite normal prices, like maybe 20 or 30 million, you can buy a pretty decent Learjet, and can take you from here to Greece in around maybe 9 hours or 8.5 hours or something like that. And it will be also a very pleasant flight, because you can do amazing things in your private jet. Even though this is the case, that you need a lot of money to maintain them. That's what holds me back, I think. Okay, so prices together with income has to do with, okay, you like and you need something, but there is also the affordability factor. And I have broken here the affordability into two parts: how much this costs and how much you you are able to pay because you have income or because you have wealth. Now, income and wealth, they are different things. Income is a stream variable. It's something that the money that comes in every period, every day, every week, every month, every year. This is income. It's a flow variable. It's a flow. Okay, while the wealth is the stock of this flow. How much has already been deposited in your account from the previous incomes or from where the endowment where you started from. All right, so these are the basic parts of the answer to the consumer decision. Now, let's talk a little bit about the budget constraint. So from this point, we will start talking about the mechanics a little bit, the technical part. Wait a second. If you think that, oh, I'm not going to become an economist, I'm not going to become an accountant, I'm not going to become something that I will deal with economics and money and accounting and finances and stuff like that. Here, we are not talking about the technicalities of any of those things, the technical background of any of those things. Here, we are talking about the technical part of how we make decisions. Any decision involves economic way of thinking. We will talk more about that a little later. Let's get started now. The budget constraint is a line like the lines we saw in the previous tutorial about graphs and equations, video 1. So it's a line, it's a straight line that shows all possible combinations of goods one can buy. All right, one can afford to buy spending their entire budget. So let's assume here, because I want to place all these things in a graph, and graphs have a problem that they show information very nicely, but they only have 2 axes. If you have a 3D graph, it gets very messy. If you have a 4D graph, you cannot have a 4D graph, at least you cannot have one that you can visualize. But we need here to split our goods into 2 major categories. So you split your decision between 2 different categories. I'm going to split them here, food and entertainment. And by food, I mean, let's say, all the necessities, the thing that you really, really need in order to survive. And then entertainment is everything that you need, not just to survive, but just to have a good time. All right, so food is, let's say, all the necessities, and then entertainment is the things that they are the little luxuries of life, that they are also necessary, but at what degree? So we have to make a decision between how much food and how much entertainment we are going to consume. We have a budget, and we are going to distribute this budget between food and entertainment. And as we already said, we are going to place it in this nice graph. My graph makes it up to 6 meals per day. Who eats 6 meals per day? Anyway, so 6 meals per day and 12 hours of entertainment. 12 hours would be a lot of entertainment, unless you are a gamer, in which case even 26 hours of gaming for some people are quite few. I had quite some friends that we had to send the police to their homes to check if they were okay, and it turned out that they were playing the video games. And back then, when I was in that age, video games were not even that good as they are today. All right, so we split this budget that we have into those 2 categories, and then we count entertainment, let's say, hours on the vertical axis, and then food, let's say, meals in the horizontal axis. And we will see how many of these combinations, like for example, can I consume 4 meals and 8 hours of entertainment together? This is the kind of question that I want to answer with this kind of logic here. So assume that our budget is $50 per day, and the price of food is 10 per unit, $10 per meal, and the price of entertainment is $5 per unit. Let's be a little careful here. It sounds very simple, but here's an advice, and please write this down on your notes with big letters, that difficulty in economics is hidden behind simplicity. Okay, the simpler something it is, the more difficult it will end up being. All right, and here's why. Because this sentence everybody understands. Assume that our budget is $50 per day. What does it mean? Do I have to spend my entire budget? Is this budget just for food and entertainment, or can I use it to save it? Or can I also borrow money on top if I judge that I'm getting hungry too much and I need to play another 4 hours of Fortnite that evening? Okay, so we have to be able to understand exactly what we mean here. So these $50 are the dollars that you have already decided that you want to divide between those two goods or services, between food and between entertainment. So you have already decided that. If you want to do saving, you should be doing your saving before you allocate a budget for this group of goods. If you want to borrow money because your income is not enough, then in this case you have to borrow money before, and after you borrow, you will decide how much your budget for food and entertainment will be. All right, so this is a budget that is dedicated entirely to food and entertainment. Now, at maximum, with these numbers that we have here, we have $50 and the price of food is 10 and the price of entertainment is 5. If you spend all your money on food, then you can get up to 5 meals, because $50 divided by $10 per unit will give you 5 units. You can find this on the graph right here. So 0 entertainment and 5 food. I get this point here. And then if I spend everything on entertainment, then my $50 divided by $5 per unit gives me 10 units. I should get a point somewhere there, exactly. And then you have to take a ruler and connect these two lines here with this red line, and this is my budget constraint. This is a very useful line because it doesn't only show you what is your maximum consumption of those two in the corners, like in this lower corner here or that corner right there, but it also shows you all the intermediate combinations. So you can actually go to any point on this line that you want to. Again, the assumptions that this line is based on, because here we try to model behavior. This means that our model should have some strict assumptions. Everybody should make what is allowed and what is not allowed in this particular model, or else our results can be whatever. First assumption, after you have decided your budget, there is no borrowing, there is no saving. You have already saved, you don't want to save for the budget that you have already dedicated to two goods. If you are doing this, it means that you are not very smart. So you made the decision to save, and then when you went to the supermarket to buy food, or you went to the store to buy something for entertainment, you having second thoughts about how much you saved, and you're doing that. It means that here we have to do with people that they know what they're doing. This is the kind of assumption for the model. So consumers, after they have decided on the budget, this $50 in this particular example, they neither save, they nor borrow. Consumers can buy even non-integer quantities, meaning that you can be somewhere there, for example, where you have 275 and 4.5 units. All right, so it's allowed to get even non-integer values here. Consumers can buy any combination on the budget constraint. By can here, with my accent, I don't know if you get it, I mean that word. With can, we mean ability. They're able. Okay, I'm not saying it to be kind. Yes, you can. Okay, I'm not saying like that. Yes, you can. You are able to do that. So they are able to be on any point they want on this line. So for example, they can go to 8 and 1. They can go to 6 and 2. They can go to 4 and 3. They can go to 2 and 4, anywhere in between these 2 points. They can even go to the corners. They can go anywhere of the infinite points of this dark red line. All right, they are able to do that. Consumers are also able to go to any combination is inside the line. Okay, inside this triangle made by the axis and the line. But if they do that, they shouldn't want to do it, because this means that, as we said before, they are not very smart. Okay, so you dedicated some money to go and buy something, and then you're having second thoughts. All right, so we are not considering this kind of individuals. In reality, of course, I'm not saying that everybody who has second thoughts is an idiot. What I'm saying is that in our model, we assume that people think just once. And this is pretty close to giving us very good results, so we do not actually question that. In reality, sometimes I even have second thoughts. I dedicate the money to go buy something, and then I go to the store, I see it, and I'm like, you know what? It's not that great anymore, so maybe I should not buy it. Maybe I should save the money to buy something else in the future. Okay, so second thoughts are not stupid. In this particular setting, though, the decisions that this person has to make are so simple that we assume that they can do it in the beginning. All right. So you don't want to be inside this inside the budget constraint. That's not great because you are losing utility. If you are inside, it means that you will be, let's say, here, and then means that you can get one more meal, or you can get 2 more units of entertainment, or you can even go here. So having extra utility from the money that you have already allocated to something. All right, so in this case, we assume that yes, you are able to be inside the budget constraint, but you don't want to be inside, you want to be on the line. Consumers cannot buy any combination outside of the budget constraint. They are not able to afford it to go outside. You can go outside if you get a raise, so you have higher income and you allocate more money, or you just decide that you're going to be saving less or borrowing more, and you will again allocate a higher budget, or you get a better job, or prices change. Okay, but given the prices of these two goods and given your budget, you are not going to be able to go outside of the line. Okay, so you are limited to be either inside or on the line, and we said because of rationality, we assume that every rational consumer will want to be on this particular line. All right, so why do we need to know all this technical background? The reason is that not only for decisions that they have to do with finances and economics and accounting, with any decision the human mind can take, there is always the same process that is going on. You have to take some resources and allocate these resources in an optimal way to more than one destination. 2 destinations, 3 different purposes of the same allocation of your resources. In other words, in logic, this is called a constraint optimization problem. You try to optimize under some particular constraint. Here, your constraint is this one, which is your income. It shows you what is feasible for you to do and what is not feasible. Like, for example, for me, buying a bicycle is way inside here, my feasibility set. Buying a private jet is way outside this particular feasibility set. All right, the same thing happens also with many other things. You do not decide only in your life about food and entertainment. You might want to decide if you're going to ask for a date to Maria or with Sophia. Again, you have to distribute some limited resources, you have to pick just one person, and then you have to understand what are your constraints in this kind of situation. What is your ability to do, where you have access. Like, for example, maybe Maria is within your league and maybe Sophia is out of your league or something like that. Okay, so this applies to any decision making, the analysis that we will do here. So we try to check what happens under the hood of human decision making. It's not strictly economics. So if I consume 2 units of food, so I'm going to be at point A, this means that my budget will be enough for 6 units of entertainment. So that means that I made the decision to consume 2 meals a day. Automatically, this means I can receive up to 6 hours of entertainment. That's not bad at all. Now, if I consume 1 more unit of food because 2 meals a day turns out that they are not enough, and now I start to want to have breakfast also, means that I have to jump to this point here. And if I maintain my 6 units of entertainment, you see here, I'm going to go outside of my graph. And that's not something that I wanted, but it's not something that is very feasible in this case. So therefore, if I want to indeed have a 3rd meal a day, this means I have to decrease my entertainment hours to 4, so I will go to point B. I give up 2 units of entertainment, 2 hours of entertainment for having breakfast. All right, so because I cannot afford both the extra 2 hours of entertainment and breakfast. All right, so the budget line incorporates the notion of opportunity cost. We see here that 1 unit of food costs me 2 units of entertainment. Like 1 unit of food, as we saw, it costs $10, but the real cost is not the $10, because who cares about the paper that says $10? What you care about is that you're going to lose 2 hours of entertainment for that. On the reverse, 1 unit of entertainment costs 0.5 units of food. Monetary prices help calculate the real cost of good. So the monetary prices are just proxies for value, as we said in the very beginning, meaning that we use them in order to be able to understand what is the opportunity cost. Budget constraint and opportunity cost are 2 concepts that they are very well connected. So the opportunity cost of food is calculated as the units of entertainment that you have to sacrifice over the units of food that you receive in exchange. So this is exactly how we discussed it before. Mathematically now, the opportunity cost is given by the budget constraint slope. All right, so here we have the slope of this line that is actually the opportunity cost. The line is entertainment equals 10, because you see, like we said in the previous tutorial video, we start from 10 and we go down with 2 units for 1, so we have 2 times food. So the equation is entertainment equals 10 minus 2 times food, and this yields the slope to be -2, as we said in the previous video. And in this case, we understand that the opportunity cost is 2. So as the budget constraint is a straight line, the slope is constant, and therefore the opportunity cost is going to also be constant. So the opportunity cost is the ratio of prices, because if you know the ratio of prices, then you can understand the way that you have to sacrifice one thing in order to receive units of the other. So the opportunity cost of food is the price of food over the price of entertainment. The opportunity cost of entertainment would be the price of entertainment over the price of food. All right. Now, one other thing, and why I'm telling you that sometimes things might sound very simple, but you have to understand them very, very well in order to be able to answer questions. Something that usually tricks students is that in this graph, we have entertainment on the vertical axis and food on the horizontal axis. That is why my equation is given like that. The variable on the vertical axis is always on the left, and then we have the expression which is with respect to the variable on the horizontal axis. All right. Now, somebody else, somebody who would like to trick you somehow, or sometimes that you change the goods, but you do not really understand the difference, so you do not have food and entertainment anymore. You have, let's say, pizza and burgers, or books and movies, or anything else. So you have to be careful, okay? When you're talking about the slope of the curve will be different if you have entertainment on the vertical axis and food in the horizontal, or somebody else might put them the other way around. Food on the vertical axis and entertainment on the horizontal. In that case, the slope will be -1/2, the reverse. Okay, so you have to have in mind that the slope gives the opportunity cost of what is in the horizontal axis over in units of what is on the vertical axis. What if we have a change in price now? Assume that the price of food decreases, and instead of $10, now it is only $8. This means that we can now afford more food per unit of entertainment sacrificed. All right, because now food is relatively cheaper. So the opportunity cost of food is $8 over $5. This will give me 1.6. The x-intercept now is not relevant anymore, because this 5 comes from dividing 50 with 10. Now the new intercept, the new horizontal intercept, should be 50 divided by 8, and this gives us 6.25. So I should go and find the point 6.25 somewhere there, and then once I do this, I'm going to make another line, dark green this time, and this will be my budget constraint when the price of food becomes cheaper. So this means that a little more combinations become feasible now. Okay, I'm going towards being able to afford at some point this private jet I want. All right, so combinations of entertainment and food with higher quantities can now be afforded because price of one of the two goods became cheaper, and I can take advantage of that. So before we had this to be affordable, now we also have this to be affordable. So therefore, I have a bigger area that I can afford. Now, assume that before the price decrease, I had selected for my own reasons to be at point A, where I consumed 4 units of food and 2 units of entertainment. So you can go to a point like B, where you increase the quantity of food that you consume. Or if you say that, listen, double breakfast and lunch and dinner is quite fine, and then I'm not going to be able to go to that date that I want if I increase my meals to more than 4. Maybe I can do something else. I can just have 4.5 meals, let's say, and I can also increase the amount of entertainment I have, or even better, I can do something else. I cannot increase my quantity of food at all, even though food is the one that became cheaper. So I will just take advantage of the decrease in price of food and increase my entertainment. So now I save money from food and I spend them on entertainment. Price of food went down. I didn't increase the quantity of food. I just increased the quantity of entertainment. In other words, you do get more utility in either B or C or D, depends on what you're taking your utility from. So somebody who goes to B is like, oh, 4 units of food is too little for me, I'm going to increase the food, and that's how I'm going to get my extra utility from the decrease in price. Somebody else can say, let's mix. Let's get a little bit more food and a little bit more entertainment. Somebody else can say, no, food is enough. I will get my extra utility from the from the decrease in price, which is always good news for the consumer. I will get the increase in my utility from increasing only entertainment. Now, let's generalize things. Let's suppose that you have anything you want on the horizontal axis, X, anything you want on the vertical axis, Y. Then if you want to find out what the budget constraint is going to be, you have to take your income or your budget. Here I assume that the budget is the entire income. You might write budget there, I don't mind. So you take your budget and or your income and you divide by the price of Y. And then you take your income and you divide by the price of X. So that's how you understand at which point is your vertical intercept and at which point is your horizontal intercept. Once you do that, then you have your budget constraint in a much more generalized way. I did exactly what I did before for food and entertainment. So decrease in price of X from a price Px that was initially to a price that is lower than Px, and I denote this by Px prime. Px is the old price, Px prime is the newer, lower price, in other words. So if Px, for example, was 11, now the Px prime can be 9 or something like that. Then the decrease in price, you have the same budget divided by a smaller price, so we'll give you a bigger number, will be on the right of the previous intercept, meaning that your constraint will have to rotate outwards around the y-intercept. The y-intercept is there, and you see it's pinned on the y-intercept and rotates around as a center the vertical intercept. All right, so it rotates outwards like that. All right, if you have the opposite, an increase in price of x from px to px double prime, so px double prime is a bigger number than px. This means that, again, nothing is going to change here because px is not involved in the y-intercept. But here you are going to divide the same income with higher price, so it will give you a lower number. And then again, you have a rotation of this budget constraint, but now the rotation is inwards around, though, the same center because the vertical intercept does not change. All right, so this means that, in general, an increase in the price of whatever you have in the horizontal axis, an increase in the price will bring your constraint inwards, will constrain you more. In other words, a decrease in the price will rotate your constraint outwards. In other words, it will constrain you less in your maximization of utility process that we will soon explore. All right, what if you have the opposite now? You have a price change for the variable that you have on the vertical axis. In this case, we have a change of price of y, decrease of price of y to py prime. Py is not involved here, so this point will not change. So now we will have a rotation again, but now the rotation will be around this center right here. So if I have a lower price, this means that my intercept will be higher because I'm dividing with a lower number, with a lower price. So my budget constraint will rotate again outwards. It will constrain me less. It will be less tight in this case. And then an increase in price of y from py to py double prime will make the constraint tighter because we divide now with a larger number, so it will be a smaller overall intercept and will make the constraint to rotate inwards, make it more constraining for our choices. It makes less combinations affordable to us. What if we have changes in income? If you have change in income, income is involved in both intercepts here. If you have an increase in income from income to income prime, or you allocate more budget in the other way, Again, by income here, I assume that it's the budget, it's our entire income. I don't consider saving or borrowing or anything else like that. So if you have a higher income, this means that your constraint now will have to shift outwards, so both intercepts will become larger, and you will have a shift outwards. Again, you relax your constraint because you have more income now, you can afford more combinations, and the opposite will happen if you have a decrease in income from income to income double prime. Then in this case, both intercepts will become lower and the curve will shift inwards, making it more difficult for you to afford combinations of X and Y. So combinations of X and Y with lower quantities will be able to be afforded if the income decreases. Okay, so this is with respect to the budget. Let's now start talking about utility and how we can use utility in order to explain, to discover, to study what happens with decision making. So, again, with respect to consumer choice, consuming goods yields utility to the consumer. That is, units of satisfaction or units of pleasure. All right, so in other words, we try here to measure how much happy or how much satisfied or how much pleasure consuming something, making a decision, in other words, gives you. Units of utility do not have an absolute meaning, and they are useful only to compare alternatives. So our target here is not to assign objective values to utility. Our objective, our target, is to rank different alternatives. So for example, you ask me, do you like more pasta or pizza? I will tell you that for tonight, I'm in the mood for pizza. All right. If you ask me, how much do you like pizza? I can give you a number. I can tell you 11,000. It's like, okay, and how much do you like pasta? It's like 10,500. This kind of numbering actually leads to the result that we want. I can rank the two things and I can say that I do prefer pizza to pasta. Somebody else can say, no, I like pizza 13 and then I like pasta minus 11. Again, this serves the same purpose. We can rank them in the same way. Here's an example that we can illustrate how this works. Going to the football match gives me 52 units of utility. What does this tell you? Nothing. Okay, you by itself, out of context, this says nothing. It's like you get an American person and you tell them, tonight the temperature will be 27 degrees Celsius. The American person will look at you, what does this mean? All right, because they measure temperature in a different way. So by itself, it doesn't make any sense. How does temperature make sense to you in Celsius that I guess in Singapore a temperature is measured? How does it make sense? Because you go out and you're cold, well, not in Singapore. You go out in Singapore and you're hot in one day and you look at the thermometer and you're like 27. Okay, 27, it's hot. And then you go out the other day and it's very hot, because that's the two options, hot and very hot. And what is the temperature? 32. So you get a feeling of what is 27, what is 30, what is 32, what is 34. So experiencing the different temperature is what gives you a sense of how cold or hot it is in a particular day. So if I give you this, it's exactly the same thing, 52 units. It doesn't tell you anything unless you have other numbers to compare it with. So going to comedy club gives me 101 units, which means either two things. I'm not very big fan of football, or I do love comedy too much. So you can see that and say, okay, Kosmas likes going to the comedy club more than he likes to go to the football match. All right, here are the common sources of misunderstanding. Utility is an ordinal measure, not a cardinal measure. If it was a cardinal measure, which is not, you could say that Kosmas likes comedy twice as much almost as football. So in cardinal numbering, the differences also matter. Okay, but if I tell you, for example, that I ran the marathon and I came first, and then another person came second, this doesn't mean that they made double the time that I made. Maybe they were 1 second slower than me, maybe they were 1 day slower than me. All right, so the first and second and third place actually is ordinal measure. If I give you the time that I took to finish the marathon, you can figure out, if you know all the times, if I was first, but also you can figure out the differences. Here, this is an ordinal measure. It matters only to put things in order. It matters only to tell this guy likes comedy more than football. That's the only thing that this tells you. You can say that I enjoy going to comedy club more than going to the match. You cannot necessarily say that I enjoy comedy almost twice as much as football. You cannot say that. And you cannot also say that if I give you 2 tickets for the football match, then you will prefer this over 1 ticket for the comedy club. You cannot say that. You cannot say that. Maybe it's true, but it's not definitely true. If you give me 2 tickets, I'm gonna take somebody and then I will have to explain to them for half an hour what the offside is. So I'm gonna have less units of utility from 52. All right, so it doesn't necessarily mean that double the 1 unit to 2 will give me double the utility. That's necessarily not the case, and most of the times actually is not the case. All right, so what do you want to do as a human being? You want to maximize your utility. You want to maximize your satisfaction. This is something that we have seen people doing. People are quite rational when they try to do the best for themselves. And also, we have seen it in animals. All right, you see that even animals, they try to do things that they maximize their utility. So scientists, they have taken behavioral economists, they have taken mice and they give them different tasks for which they reward them. And you see that the mice are making decisions that they are quite consistent with utility maximization. They try to maximize their satisfaction. We know that plants are trying to maximize their satisfaction. Plants like to get sun. Now we see that the plants will try to expose themselves to sun when they are in difficult conditions, like for example, you put them in a place that they don't have so much sun, or they are in the forest under other bigger plants that they do not have easy access to the sun. They will do everything in order to maximize their exposure to the sun. All right, so this is an axiom that we see that holds not only for people, it holds for animals, it holds for plants. For anything that is alive, will try to maximize the satisfaction that gets from the conditions that is exposed to. We naturally then tend to choose what maximizes our utility. If we consider the example that we had before, food and entertainment, here is a table, and I want you to pay attention to the table because there is a lot of information that is going to be conveyed to you by those numbers. So in the first column, I'm going to give you the units. Units of food or units of entertainment. This is the number of units. All right, so the first row is for 1 unit of food and entertainment, 1 unit of food, 1 unit of entertainment, 2 units of food and entertainment, 3 units, we go up to 7 units and then up to 8 units. There is one value and keeps going the same after the 8 units. Now, here's the utility from the first unit, 120 from food, 180 from entertainment. So if I consume 1 unit of entertainment, I get 180 units. If I consume 1 unit of food, the first unit of food, I get 120 units of utility, of satisfaction. If I double my units now, 2 units from each, then utility is going up. The more you consume, the utility increases and increases and increases and increases for both. All right, so utility is increasing. Now, depending on what kind of assumptions you have, usually we say that the more you have of something, the more satisfied you will be. Okay, so the more I give you of something, this is extra thing given to you, you will enjoy more and more. In some other cases, we assume that utility is not always increasing. It reaches some point, then becomes stable, and then consuming more and more doesn't give you any more utility, meaning that it reaches a point that this adding more quantity becomes totally pointless to you. It doesn't give you any more satisfaction. Like, for example, if I have 300 shirts, or if I have 600 shirts, that's not going to give me any more utility, because assuming that I'm not selling them, I'm not using them as pure value, because if I have 300 shirts, that's way over the number I need. Having even more doesn't give me any utility, just makes me need a bigger closet. Now, in some other cases, we may assume specifically, and this becomes clear with a problem at hand, that after some consumption, you start having negative utility. The utility that you receive from the extra units afterwards becomes negative. Like, for example, I love cheesecake. I get a lot of utility by having 1 piece of cheesecake. Then second piece gives me a lot of utility, but not as much as the first one. The third piece still gives me a little bit more. The fourth piece gives me just guilt. And the fifth piece makes me really sick to the point that I regret having any cheesecake that day. Okay, so my utility actually at some point starts decreasing after consuming too much. Now, depending on which model of the 3 you follow, the one that utility is always increasing or at some point stabilizes and doesn't increase, or at some point it goes down, this will become clear from the problem that you will have at hand. If it does not, you can make your own assumption. In this course, you will not need to make your own assumption. It will be clear. So here what we see is that utility increases for both of them up to 8 units. We have this point at the 8 units that utility decreases just a little bit by only 1 unit. I want you to observe that as I add units, my utility keeps increasing, but keeps increasing less and less. So, the marginal utility of the first unit, that is the utility of the last unit, which is also the first here, is 120 for food. So I got from 0 to 1, I get an increase in utility 120 units. When I go from 1 to 2, my utility doesn't double as the units do. My utility goes up again by a lot, by 90 units there, but less than before. Then keeps increasing by 80 units, then keeps increasing by 50 units, then by 35 units, then by 20 units, then by 2 units, and then by only 1 unit. So we see here that the utility of each extra unit, this is called the marginal utility. The marginal utility is the utility from the last unit that you consumed, from each extra unit. So marginal utility from both of them is actually decreasing. This is something reasonable to expect. It happens with any kind of consumption, any kind of decision making. The first unit of something is most likely, with very few and very peculiar exceptions, almost kind of unreal. We see that the first unit is more valuable than the next one, and the next one is more valuable than the even next one. So we see that marginal utility is natural to diminish as something becomes more. The importance of each additional unit becomes less and less and less. That's the meaning in this table here. So let me bring back my graph with my budget constraint, and we will examine. All right, so the budget constraint gives me what? Feasibility. Which of the combinations are affordable, I am able to consume. And we said that we are gonna go on the budget constraint because we are smart. And let's consider the ones, only the choices here that they involve combinations that they have whole numbers, even though we can go in between the dots here. Let's see what happens in those dots. So if I consume 10 units of entertainment and 0 units of food, I will be right here, my utility will be 0 from food and 260 from entertainment. I get 260 total units. If now I consume 8 units of entertainment and 1 unit of food, again I get 260 from entertainment because I'm above the 8 units, but now I consume 1 unit of food, so I get another 120. I improve my total utility a lot. If I go down to 6 units of entertainment and I consume 2 meals a day, then I will get 258 from entertainment and 210 from food. That will give me 468. I'm improving even more. Then for 4 units of entertainment and 3 units of food, I am receiving 545 total units of utility. If I go for 2 units of entertainment and 4 meals, then my total utility will be 340 plus 230. This will give me 570, which is the best value so far. And then if I consume only food, I get 5 meals a day, which give me 375 units of utility, and that's not as good as it is the point 2 and 4. So clearly here we can see that if I have to select among all these feasible points, my final decision should be for 4 units of food and 2 units of entertainment, because this gives me the highest utility according to this table. This is very easy when you have somebody to explain it to you. However, it's very usual that students will find it difficult when they have to do it themselves. So I would say that you actually go in your own time, you try to practice a little bit and to see what the numbers here, where the numbers are coming from, and how we end up of making the decision of consuming 2 units of entertainment and 4 units of food. I think this will help a lot in order to understand here. All right, what about the optimal choice now? This one will be the most difficult slide of the whole lecture, perhaps one of the most difficult for the entire course. And I want you to be like totally 100% here when you go for it. It's difficult for me also to explain it. I have rewritten this slide over the years several times, and even probably today, it's going to take several takes for me in order to film it the way that I want to explain it, because it's even difficult for me to explain it in the best possible way. So make sure that you are 100% here, and let's try to understand what is the condition that guarantees that our decision is the best decision. When is our decision the optimal one? This is what we want to understand now. So when you pick the combination where the consumer maximizes the utility, so when you make the choice that is the optimal choice for you, a condition, a rule, and a mathematical equation has to hold true, has to be true. This is the condition. It means that you have two goods, X and Y, let's say food and entertainment or anything else you want. The marginal utility from X over the price of X should be equal to the marginal utility of Y over the price of Y. All right, let's put a comma here. First of all, what is a mathematical condition? A mathematical condition is an equation that checks something. All right, so if the condition holds, something is true. If the condition doesn't hold, this thing is not true. This condition doesn't have to hold all the time. It holds only if you have made the best decision, the optimal decision. If you don't want to make the optimal decision, you still can. This equation just is not going to be true anymore. So a condition is something that holds and then makes something else to be true if it holds, but doesn't have to hold. Okay, like for example, I can tell my nephew, go make your room or else you are not gonna go to the excursion on Saturday. Okay, he can make the room and therefore he will go to the excursion on Saturday, or he can choose not to do it and be like, I don't even care for this excursion, and he will not make his room, so he will not go to the excursion. All right, so this is a condition. Fix your room, make your room, tidy up your room is a condition. If it holds, something else happens. If it doesn't hold, the other thing doesn't happen. All right, so here is our condition. Okay, what does it mean? What even those things mean? First of all, MUX is the utility of the last unit you consumed from X. MUX is the marginal utility from X, the utility from the last unit you consumed of X. MUY is the same thing on the side of the Y, the last unit of Y you consumed, how much satisfaction it gave you. The left side, MUX over PX, is the marginal utility of X divided by the price of this unit. In other words, the left side, this fraction on the left, is the utility that the last dollar spent on X gave you. Spending a dollar, the last dollar on X, how much satisfaction did you get from this dollar? Okay, so now instead of having to do with the last unit, you actually divide by the price and you get the utility of the last dollar, of the marginal dollar that you have there. The other side is the marginal utility of the last dollar spent on Y. So if the marginal utility of the last dollar spent on Y is equal to the marginal utility of the last dollar spent on X, this means that you have made the best possible choice deciding how much X and how much Y you will consume. Meaning that your adjustment in quantities, how much you will buy from each, is the best, is the one that gives you the maximum utility. Why is this true? Imagine now that, let's say, X is food. So if the utility from the last dollar of food was 20, and the utility from the last dollar of entertainment is 30, it means that your dollar that you spent, the last dollar that you spent on food, didn't give you as much satisfaction as the dollar gave you spent on entertainment. Meaning that perhaps that dollar that you had spent on food, the last dollar, would be better to change side and go on the other side, go on the side of entertainment. Why? Because if you spend your money on food and you're not getting a lot of satisfaction, and then you spend your last dollars in entertainment, you got a lot of satisfaction, maybe this is a sign that you should take some dollars from the side of food and transfer them to the side of entertainment. Now, this is a balance. As you take dollars from here, the utility increases. Why? Because the marginal utility, as we saw before, is decreasing. So if you take dollars from the side of food, this makes the utility, the marginal utility of food to actually increase because now you consume less units of food for which the utility is higher. All right, so you should be spending more on entertainment, which gives you more utility for your buck. But as you increase entertainment and you decrease food, the two sides will tend to converge because utility from the last dollar of entertainment will decrease because now you consume more units of entertainment and the utility from the other units will be less than the previous ones, and the reverse will happen in food. Now you consume less food, so the units of utility that you will receive from the initial units of food, because you're getting rid of the later units of food, you're not buying them anymore, is higher than the later units. So, if the situation is something like that, food is here, entertainment is here, this gives you much more utility for your buck, much less utility for your buck. Why? Because you consume too little relatively on this, and too much on this. That's why the utilities are like that. If you transfer dollars from here to there, on that side, then this means you are going to consume less of this, so utility will go up, and more of this, so its utility will go down, and then at some point they will balance. Once they balance, then you have this equation happening there. Once this happens, you have no reason to transfer dollars from here to there or from there to here. There's no reason to change the balance anymore because you have made the optimal distribution of your budget to the two goods. So, utility from the last dollar on entertainment will decrease as you increase entertainment. Utility from the last dollar on food will increase because you consume less food, and this is exactly why this condition is true. This is difficult. Perhaps you have to see the segment more than once. If you still have questions, we explain it also in the problem set number 2, and also you can always ask your questions down below in the comments, and I will make sure that I will come and answer any questions you might have. Okay, so this is what we had to say about the budget and what we should know about utility. Now we are ready to investigate what happens with demand. Demand as a relationship. Okay, so what makes people demand something? What exactly we mean by demand? We said that demand is the one side that determines value. So what exactly it is? So demand, first of all, is a relationship. And everything that I say from now on will be crucial for you to understand what demand is. So I will keep the discussion very, very minimal, but please try to understand it as deeply as possible because all of this will be super useful for you. So demand is a usually negative relationship between two different variables. The first variable is the price of a good or a service, and the second is the quantity demanded of that good or the service. So, again, terminology, very important terminology. Price and quantity demanded, they are two numbers. Price can be $10, quantity demanded can be 3,000 tons. Okay, so these are two numbers. There is a relationship that tells us how these two numbers are related, how one responds to the other. This relationship is demand. Therefore, lesson number 1, super important. Demand is a relationship. Quantity demanded is a variable. This means that quantity demanded is a very different thing than demand. Quantity demanded is a quantity in kilos, in tons, in pounds, in everything you want to measure it, while demand is actually a relationship, an equation, something that tells us how two things are related to each other. All right, so let's get started. Demand reveals the willingness to pay. This relationship depends on the willingness to pay for a given number of units or a product. The willingness to pay is derived from the process of consumer choice we described earlier. So for example, what is my willingness to pay for a private jet? Much smaller than what it costs. Okay, what is my willingness to pay for, let's say, a Vespa? That could be something that could actually end up making the choice of buying these things. So it belongs to my feasibility set. So how do I derive my demand? Give me the price of the good and I will tell you how much quantity I will buy of these things. So if you tell me, for example, that one suit costs $10,000, I would buy only one. If you tell me that one suit costs $300, maybe I will buy 5 different ones. All right, so you give me the price, I tell you how much I will buy. This shows the demand relationship. This is a basic way that you conduct a basic survey and you derive the demand relationship for a good or for a service. Let's try to do that. I have made a specific example here. My demand for services at the Indian restaurant. So Indian food is amazing. It's the second most amazing food in the world, the Indian, according to my subjective opinion, of course. So here is a schedule regarding meals per month I would like to eat to that particular Indian restaurant at different prices. So if you ask me, how many times are you going to be eating at this restaurant per month? I will have to know at what prices first. Okay, it will be a different answer if the price is $300 a meal. It will be a different answer if the price is $3 a meal. All right, so here is the price and the quantity. Price is in dollars, quantity is in number of meals. I will survey myself for prices between $10 and $35, and we will see what my answer is going to be. And once we have this nice table here, it will be much better to put it in a graph also so we can visualize the information. So I have the quantity on the horizontal axis in number of meals and the price in Singaporean dollars on the vertical axis. All right, so I'm going to be giving you the numbers, survey myself, giving you the numbers on the table, and then we will derive them on the graph. So if you ask me how many times I will visit that restaurant per month if the price is $10 per meal per person, I will go there twice a week. That's 8 times a month. So this means that if the price is 10, I will visit 8 times. If the price goes up to $15, then I will go 2 times a week and then the next week 1 time. This, if you repeat the cycle over a month, it will give me 6 meals a month. So with $15 a meal, I will visit 6 times. This gives me this point, 15 and 6. If the price goes up to 20, I will go once a week, 4 times a month, which will yield this point right here. If the price is $25, I will just miss 1 week because it's starting getting quite salty now and expensive. So this means that I receive the point 25 and 3. If the price climbs to 30, I will go there every 2 weeks, so 2 times a month. This will give me the point 30 and quantity 2. And then if the price is $35, then I will just visit 1 time a month, and this will give me this point 35 and 1. If we connect those points together, we receive this negative relationship that we were talking about before. So, again, because this is really important and a lot of students confuse it. And the bitter truth is that no matter what I say, at least 30 to 40% of the students will keep confusing demand and quantity demanded, even though I say it so many times that it becomes extremely boring. I listen myself when I'm editing the videos, how many times I said this thing, and still students get it wrong. But it seems that it's not going to happen because people just hear just the surface of things. They don't want to go a little deeper. So look at that. Demand is a curve, all right? It's an entire curve. It's set of prices and correspondence with quantities. That's what demand is. Quantity demanded is just a point. Like here it's 6, here it's 4. But it's the same demand. So in the same demand, you can have all quantities that they correspond to different prices. Again, quantity demanded is a variable, demand is an equation, a relationship. Totally different species of things. All right, they should not be confused so we know what we are talking about. All right, so demand is a relationship that shows how quantity demanded responds to price. As we said, for example, if I give you a demand function Q equals 14 minus 2 times P, this means that if the item was free, I would buy 14 units. So P would be 0, 2 times 0 is 0, so Q would be 14. So if the item was free, I would buy 14 units. Then if the price starts going up, for every dollar increase in price, I would buy 2 units less than 14. So if the price is 1, I would buy 12. If the price is 2, I would buy 10, etc. So instead of giving you this little table, I can give you this much simpler and easier equation, and provided that you are not scared of it without a reason, because I know that a lot of you are scared of these equations, but I can tell you that you have no reason to be scared of equation. It was never in the history of the science an equation anytime ever attacked somebody. Okay, they are totally harmless. You look at them, they look at you, doesn't matter, stare at them, they're not going to get aggravated, stare at them as long as you need to understand them. And another trick when you understand economics, and this will be super useful, never look at the full page of economics and say, oh my God, that looks like super difficult alphabet for me. You should always look equation from equation, because if you have several lines of equations, most of the times, even in the most sophisticated papers, the one equation in the first line is almost the same like the equation in the level below, because they just one simple thing happened from one line to another. So it looks a lot and it looks scary and it looks difficult, but if you follow it line by line and you are patient, it will never turn back and bite you. It will, the equations are difficult to understand only if you are scared of them, but you have no reason to be scared of them. And in this course, the level of math that we will do is so minimal that actually I can take a student 12, 13 years old, and with the math that they know from junior high, the first, second grade of junior high, they can still know enough to get by in this course. So don't be afraid of the technical part. Sometimes it will be there to make your life easier, not harder. All right, so by having this simple equation here, I can derive a table like the one we had in the previous slide much faster and easier. Actually, I don't even need to do it. I can take the graph, start from the intercept, which is 14, go down for 2 units for each unit of P, and here is my line with just 2 points without needing to have all these table and ask questions to ourselves as if we are surveying ourselves. All right, so if price changes, then quantity demanded will change to the opposite direction. So if, for example, P is 1, that means that quantity will be 12. If P becomes 2, this means that quantity will become 10. So P goes up, quantity goes down. This is what it means. It is a negative relationship. You don't need to look further away. You look at this minus that is before the coefficient of P, and automatically you figure out that this is a negatively sloped curve, so it will be a well-behaved demand curve as well. So if price changes, quantity demanded will change to the opposite direction, but demand will not change. So if I change P, my equation will not change, demand will not change. What will change is the quantity demanded. That's why I told you that they are different. All right, this is the job of this particular relationship. Okay, when I posted the job ad, I said I need an equation that will tell me if I change price, how is quantity going to respond? So that's the job of this equation. If I have to change equation every time that P changes, then I don't need a demand function. Okay, the demand function is a function that stays there and tells me how quantity responds to price. Changing a variable, therefore, within a relationship does not affect the relationship, it only affects the other variable. So changes in the price of the good do not shift the demand curve. All right, so changes in the price of the good do not shift the demand curve. There is a kind of a cute story with this. And the first time that I taught this class, I had a question in the test. It was either in the test or in the homework. And I was asking which of the following will not shift, will not change the demand of Coca-Cola. And of course, the correct answer was the price of Coca-Cola. The price of Coca-Cola will change the quantity demanded of Coca-Cola. If Coca-Cola becomes more expensive, people will demand a smaller quantity of Coca-Cola, but the demand as a relationship will not change. So then students started using, instead of referring to this result, they started saying that's the price of Coca-Cola theory. Okay, what is the only thing that doesn't change the demand of Coca-Cola? The price of Coca-Cola. All right, so that's how they kept remembering from this particular question. They kept remembering this fact that is difficult for students most of the times to grasp with the first trial, with the first effort. So please insist till you understand 100% what we're talking about. Then, if the change in prices do not change the demand, what changes the demand? Not the quantity, the entire demand. So there are some factors that we call them the demand shifters, and let's examine what the demand shifters are. So for a particular product, the decision of the household, of the consumers, regarding how much they will buy depends on several factors. Each of these factors can change, and then the decision, the correspondence of price and quantity will change. The entire correspondence will change. The first is the household tastes and preferences. Okay, if you have a favorable change of taste, then this will increase your demand for the particular product. Like I remember in the past, when I was in Greece we don't drink tea. No, scratch that. We do drink tea, but only when we are sick. We are 99% order coffee when we go to the coffee shop, or we drink coffee in the morning. And it's something that if you order tea in Greece, perhaps because the climate is also warm, but there are other countries that the climate is warm and they do drink tea. But in Greece, we just don't. It's not in the culture. So I went to Russia, and in Russia, it's very difficult to find good coffee around. It's Most of the times it's almost impossible. But it was very easy to find good tea. Like the worst coffee shop around would have really good quality tea because Russians are notorious tea drinkers. So I started ordering tea, and I understood that tea is an excellent beverage. Like it's one of the best things that you can drink. So I became a very big fan of drinking tea. This means that before I had some tea in my home, like usually this horrible Lipton yellow, not a sponsor, this Lipton yellow tea that just in case that some weird person comes to my home and they want tea, or just in case I become sick and I need to drink tea with honey, so it will cure my sore throat, or at least that's what I believe. But instead of that, now I have like 11 different kinds of tea, and I even bring tea like from different, every time I visit Russia again, I will bring tea, like I have tea bags. Sometimes in the customs, they look at the bags that I have with these green weeds, and sometimes it's really brings me for a second in a difficult position, as you understand. Anyway, so this means that I started appreciating this particular good. Now, no matter what the price is, I buy more. I buy more even when I came to Singapore, which tea is much more expensive than it was in Russia. I would buy because it's something that my demand curve has shifted in this case because of a change in preferences. The prices of related products available. All right, so the price of Coca-Cola does not change the demand of Coca-Cola. But the price of Pepsi does affect the quantity demanded of Coca-Cola for every price of Coca-Cola. So the price of Pepsi affects the demand of Coca-Cola. The price of Pepsi does not affect the demand of Pepsi, but affects the demand of Coca-Cola. The price of Coca-Cola does not affect the demand of Coca-Cola, but affects the demand of Pepsi. Because if I buy, let's say, 10 cans of Coca-Cola per week at the price of $1 a can, and then the price of Coca-Cola increases, I will buy less units according to my demand. But if Pepsi decreases the price, okay, Pepsi, no matter how it can try, it will never become Coca-Cola. Okay, that's the sad truth about Pepsi. But if it becomes extremely cheap, then some people will shift from consuming Coca-Cola. No matter what the price of Coca-Cola is, they will consume less just because they will shift towards Pepsi. So prices of related goods will affect the demand and can affect the demand either inversely or directly, depending on if they are complements or substitute products. And we will see what that is in the video number 2 later today. So the third factor is the household's available income or accumulated wealth. Higher income increases the demand of some goods and decreases the demand of other goods. Like, for example, now if the price of Coca-Cola goes $2 a can, I will decrease the cans that I buy. But if my income goes up by $1 million every year, then in this case, I will stop thinking about if the price of Coca-Cola is $1 or $2. I will keep buying higher quantities, even if Coca-Cola is more expensive, because I can afford it, because my budget constraint will shift outwards and I would be able to make this decision that now I cannot make. And the fourth one, and really peculiar here, is the expectation about future income, wealth, and prices. Expectations affect our decisions now, even though in some cases expectation may remain an expectation forever. If I expect that my income will go up, I may start increasing my consumption and therefore my demand of particular items today. Maybe this expectation will never be realized, will never happen in the future, but just the fact that I have this expectation for now for the future, now for the future, this means that I may adapt, change my consumption from today. So we have numerous examples of people that they think that their income will go up, they start consuming a lot, and then the income will never go up, or the income does go up and they already have adjusted their behavior from before they receive the income. Another thing that is really worth noticing here is the expectation about the price of something is not the same variable like the price of something. What you expect the price to become in the future is a very different kind of variable than what this price is now. For example, if the price, let's say, of olive oil is now $10 a liter, and it will go up to $30 a liter in the future, that's what I expect. It hasn't gone yet, nobody announced it. I just have my reasons to expect that the price will go to $30 in a month from now. Perhaps I will change my demand of olive oil now, and for the price of 10, instead of buying 1 liter that I usually buy, I would buy 11 liters now because I don't want to pay the higher price later. So expectation for the price of Coca-Cola is not the same like the price of the actual price of Coca-Cola. The price of Coca-Cola doesn't change the demand of Coca-Cola, but the expectation for the price of Coca-Cola does change the demand of Coca-Cola because it's not the same variable, it's another variable that changes the whole relationship. Now, shifts in demand for the Indian restaurant. What might shift my demand? If my demand is this one that we derived before, D0, then if my salary increases, then maybe I can afford to go more times to the Indian restaurant, and my demand will shift to the orange position, D1, and this will make me to go, no matter what the price is, I will visit the restaurant more times because now I can afford more meals there because my budget constraint has relaxed a little bit because I have a higher salary. Or I inherit $10 million. Like imagine that I had this very, very wealthy uncle that loved me dearly, and then he died, but I didn't know him. He just loved me very much, but I never heard of him. And then he gave me an inheritance of $10 million, and this made me very happy. Wait, I was very sad that he died. Well, I didn't know him, and you understand. I mean, that I would be very, very sad that the guy died, but I would be happy that I will have more money. You understand the example that I want to make. Like, that's an inheritance of, no, let's say a different example. Like a very rich prince in Nigeria wants to take some money out. He wants to take $100 million out of Nigeria, and then he wants to transfer them to my account. So he gives me 10 million just to make the transfer, which is a fair deal because I have to go to some trouble to do that. And this is a totally legit and true story. It happens very much. I know that you know there are all these spam emails that they send you. Lots of people that they pretend to be Nigerian princes, but I have met the one, you know, that he really meant it. Or the price of Italian food increases. The price of Italian food increases. I was going to the Italian restaurant once a week. Now I'm going to stop doing that because it's too expensive. I'm going to go less there, and I will shift consumption towards the Indian side. Or my doctor said that for my last blood exams, I have to increase my intake of masala because the quantity of masala in my blood is critically low, towards the low end of the spectrum, and I should increase it. So it's like I know that you have to do the sacrifice of eating more Indian food, and I will be okay, doctor, I will have some more Indian food from now on, so this will increase my demand for Indian food. Or I expect to get a high-paying consulting project. I expect to get it. I didn't get it, so it's not the same like the first one that I had the salary increase, an income increase, an actual income increase. This is just an expectation that might lead me to start spending from now, and actually we see that a lot. Now, in the opposite side, I may start a diet, in which case I will stop going to restaurants that much. I will eat at home a little healthier and a little less. And this will decrease my demand for food at the Indian restaurant. Or maybe I move further away from Little India and then I have a higher transportation cost in money and also in time to go there. It makes it harder for me to go there, and therefore I will not be able to visit this restaurant for as many times as I used before. This will be equivalent of having my demand to go down, or a recession is expected, from which I'm expected to be also affected, and therefore I will be most likely dedicating less budget towards spending for food, so I will save some more money in the future. It's as if my income has not gone down yet, but I want to increase the amount of savings just because I want security for an uncertain future because of the recession. So, see all this. This is the relationship between price of Indian meal per meal per person, and this is quantity of meals. Neither price or quantity of meals in the Indian restaurant appears in the shifters. What is it? Salary, inheritance, price of another good, nonsense about the doctor that I said before, or I expect to get something in the future, an expectation, or I start a diet, or I move further away, increasing my indirect cost of visiting the restaurant, or a recession that will perhaps make me change my attitude towards spending. All these things affect the demand. None of this has to do with the price of the Indian food per se. The law of demand now. The law of demand states that demand curves must be downward sloping, or at least to not be positive sloping. So as price increases, quantity demanded must tend to decrease. This is due to two reasons. There are two reasons that this happens, and these two reasons, they act together, one in accordance with the other. They do not, these are not alternative, they are complementary to each other. The first is the substitution effect. As the price of something increases, I tend to substitute this good with something else that the price has not increased. If the price of something increases and the price of something else has not increased, then in this case, the other one has relatively lower price than the first one that its price has gone up. So, for example, if the price of cinema increases, I may rent a movie. Okay, I will not go to the cinema, I will just rent a movie, which is, I'm just trying to substitute the service with a cheaper service, or I may just change source of how I receive my satisfaction altogether. So instead of watching a movie from at the cinema, I now can go to the bookstore and buy a book, or I can just ride a bike more often. All right, I get my satisfaction from a different way. So the substitution effect is indeed a very important effect. Okay, and number two is the income effect. As the price of something increases, then my income will not be enough to keep buying the same quantity. I cannot afford to buy the same quantity. Don't forget that because I'm a rational consumer, I'm already on my budget constraint. If prices become expensive, means that I still have to be on my budget constraint that will shift inwards. So I have to quit buying those quantities, either buy less from this thing that has become more expensive, or keep buying the same quantity but quit buying something else that I was buying before. So these two effects, they actually make the demand curve to be downward sloping, either because I tend to substitute one good with the other, with something relatively cheaper, or because I just cannot afford to buy the same quantity, and now I will start buying less. Let's now try to talk about the demand, but not at the consumer level. Let's pull all consumers together and start talking about the demand in the entire market. The market has several consumers, and we have to pull them together, to pull the demand habits of each consumer together and create a market demand. So assume here that we have three different people, A, B, and C, Anthony, Bob, and Claire, and they have three different individual demands. The market demand then will be the sum of quantities per price for each one of them. So I will take their demand curves and I will add them. But I will add them horizontally, not vertically. You will see in a moment what I mean. So here is the price. Here is how much A buys. I have enough information now to plot the demand of A, the individual demand of A. So it will look something like that. These are the quantities for each price for A. So this is the demand curve. And then this is how much B buys. And I can plot also this information. This is the demand curve of person B. And then I have person C. That's the quantities that this person buys. And again, I can plot them right here. So we see that C here consumes a little more than B and A. So we have these three different demand curves that they are for those three individuals separately. And now I would like to add it. Add those three demands, and I will receive a market demand. When you can add curves in a graph, there are two ways you can add them. You can add them horizontally, so adding this plus this plus this, and you will get something here, or you can add them vertically, this plus all this, and you can go up. Which one do you want to do here? You want to do the horizontal sum. Why? Because you have to add the quantities for each price. So for price of 1, my total quantity will be 32, 6 plus 10 plus 16. For price 2, it will be 25. For price 3, it will be 18, and you can see them also in the graph there. For price 4, only B and C consume there, it will be 11. And for price 5, again only B and C, they will consume just 6. So you can take the market demand. Don't do the mistake of adding prices for each quantity. This doesn't make sense here. All right, so you add quantities for each price. This is how you get the market demand. It's quite technical. I want you to make just a quick observation that the market demand, as you can see here, is flatter than the three other curves. Okay, just observe it because you actually add different curves that they have negative slope, each one of them. Then you will take another curve that the slope is actually smaller in absolute value. All right, some important remarks. From this analysis, we can make three important points that they are worth noticing here. First of all, the market demand will shift to the right as more consumers enter the market. If you have more consumers that they keep entering the market, you will have higher and higher demand. Not because each individual person likes the product more, but there are more persons like that product the same, but because there are more persons, the market demand will go up. Those factors that influence the demands of many consumers will also affect the market demand. Okay, so if people start liking something, then they will be willing to pay more for this thing, and it will become more expensive. Like people, for example, they like a lot of people like more and more bubble tea or Starbucks coffee, and we see that the demand of these particular items increases and increases and increases, and they have reached prices that they are not that cheap anymore. So, and the third one is what I told you already, the market demand has a flatter slope than the individual demands. Thus, the market demand is more responsive than individual demand to change of prices. The same change in price is addressed with a larger opposite change in quantity. If we have an $1 increase in the price of Coca-Cola, I will buy 5 instead of 10 cans. All right. But then if this is done by another 1 million people in Singapore, then this will end up having, like, for this $1, have a huge decrease in the total quantity, much higher, of course, than my decrease in quantity, because I'm just a little particle of this market demand. So that's why the demand curve is flatter when you are talking about the market than when you are talking about a specific person, a specific consumer, which is just a part of this market. So these are all you need to know about how demand works. I'm suggesting this super interesting video. It's a video made by CNBC. It was made for YouTube specifically. It's not part of their news segment. And you can watch how everything that we learned in this lecture will allow you to understand this piece of news much better. And this is something that is really interesting. One of the most iconic foods of the century is milk. Milk is something that is considered now in most nations, especially the Western nations, one of the most prominent foods, one of the staples of the diet of the Western world. And we see that the situation with tastes and preferences and prices and the demand side in general is actually changing. And the COVID-19 situation that was observed in the first months of 2020 in the Western world started actually accelerating this change. So we started seeing that the demand of milk was going down from before, but after the pandemic started, we see that the problem with the demand became so big that huge quantities of milk were thrown away just because they could not find buyers one way or another like they could before. And you will see that once you watch this video, there will be several terms of today's lecture that you will be able to start seeing in there, and how economics can actually help you understand the reality. All right, so this is with respect to the demand. We covered the budget, we covered the utility, and we covered the demand. And now let's talk a little bit about a very interesting measurement that is called the elasticity of demand. All right, so the elasticity of demand is a measurement of responsiveness. In general, elasticity is a measurement of responsiveness. So we use the demand in general as a relationship in order to understand the response of quantity demanded to changes in price. So we want to understand the correspondence of price and quantity demanded by the consumers. This is why we come up with demand curves. Now, one of the best measures of response is the elasticity. And you will be like, wait a second. If I have the demand curve, why do I need the elasticity to understand the responsiveness? If I have the entire demand curve, I can understand how quantities respond to prices. If I have your individual demand, I understand how you respond to prices. If I have the market demand, I understand how the entire market responds in prices. So why do I need something more? The answer is not what you expect. You don't need the elasticity of demand if you have the exact market demand or the exact individual demand, and that's what you care for, the responsiveness. But if you want to derive a demand curve, there is one way to go. You have to hire a company usually, and they will do a market survey. They will take lots of consumers, For some particular products, they might need to take thousands, a couple of thousands of consumers, give them to try the product, or perhaps they know the product, and then sit them down and have them fill a questionnaire, or usually the survey person will fill the questionnaire for them after they try to receive unbiased information in some particular tricks that the analytic teams that they design these surveys have. Now, this is something that of course can be done, and of course it is used to be done for several products. But as you probably understand, this is not affordable from anybody to just do these huge surveys. So sometimes deriving the entire demand curve may be out of reach, and you don't have the sufficient information to derive an entire demand curve. In this case, you might not need the entire demand curve. You might just need an estimate of just the responsiveness in a particular point of the demand near where you are right now. If you remember, when we derived my demand for Indian food, we started from a price of 10, we went up to a price of 35. If the price is 12, I don't need to do it for that much range. I can just do it near the price of 12, because if I'm the Indian restaurant owner and I increase my prices, I'm not going to increase it from 12 to 35. I'm going to increase it from 12 to 12 and a half or 13, or decrease it from 12 to 11 or 10. So you need to get responsiveness around the vicinity of the price that you actually are. And the best and cheapest and easiest way to do that is by using elasticity. So elasticity is one of the best measures of response for a function, and it's a measure of sensitivity of one variable to changes in the other variable. That is, we measure the percentage change in one variable that is caused by a percentage change in the other variable. Now, elasticities are used in economics, and most students, they learn them in economics, but they didn't start in economics. It's a mathematical measurement. It's used a lot in physics. It's used a lot in chemistry. It's used a lot in engineering. And it's because that's what it is. It's an engineering measure. It says, okay, if I switch this knob by 20%, how is my subject going to be affected? This is exactly what we're doing here. We change the knob of prices, and we see how humans react with respect to quantities that they buy. All right, so elasticity measures this sensitivity of percentage change in one variable due to the percentage change in another. Therefore, the elasticity is a ratio of percentage changes between two variables. Now, we have three kinds of elasticities that we will bother here. The first is the elasticity of demand. The full name of that is the price elasticity of demand. Perhaps that's how you learned it if you have done it before. But usually in the science of economics, we refer to as elasticity of demand, and that's it. Now, there is also the cross-price elasticity of demand, and there is also the income elasticity of demand. These are three types of elasticity. They all measure similar things. One measures the response of quantity to changes in own price. The other measures the change in quantity in terms of somebody else, another good's price. And the third one measures the change in quantity with respect to changes in income. So they all measure this kind of sensitivity to different variables. So the most basic one is the price elasticity of demand. We know from the law of demand that when the price of a good increases, the quantity demanded tends to fall. The question is by how much is going to fall? How is it going to respond? Is it going to respond a lot, or is it going to respond just a little? We know that they will respond to the opposite side, to the opposite direction, increase in price, decrease in quantity, but decrease how much? Okay, decrease can be $1, increase in quantity can be $1, increase in price can be A dollar decrease in quantity can be 5% or 20% or 90%. Okay, so this decrease, this correspondence to the change of price matters a lot, matters like from profits to losses a lot. All right, so let's try to see how exactly this works. The price elasticity of demand measures the percentage change in quantity demanded resulting from a percentage change in the goods price. So we see how the quantity demanded responds to changes in price. So formally, we use this letter here. This is the Greek lowercase epsilon. I'm not using the Greek notation because I'm Greek, like some students tend to say. I use it because this is the global notation for elasticity of demand. So we call it ED. This is the elasticity epsilon D. This is the elasticity of demand. I know that some of you are used to the notation ID. It's used in an increasing rate, I would say, but most books and most notations, most universities around the world, they use the letter epsilon to denote elasticity, and this is what we are going to follow. So the elasticity of demand for a product will be the percentage change in quantity over the percentage change in price. Or you can write that as the change in quantity over the quantity that you had, over the change of price over the price that you had, and this will actually give you the percentages in this in the numerator and the denominator. So it's a more analytic formula, the second one, to calculate. So the price elasticity of demand will always be negative, and will always be negative because if the change in quantity is positive, this is going to be negative because of the law of demand. And if this is negative, this is going to be positive because of the demand. So these two, no matter which side they are, they will always have the reverse signs, okay, the opposite signs. And therefore, if you have plus over minus or minus over plus, it will always give you minus in the end. So elasticity of demand is always negative. Now, your book says that usually we assign a positive number to the elasticity of demand and we mean a negative number. Well, I teach economics for almost 326 years. I didn't see this that prominent as much as in this book. Sometimes people do it, then they apologize. Sorry, I meant minus 5 instead of 5, or I meant minus 0.2 instead of 0.2, or sometimes they give you the absolute value. So in this class, we are not going to make this, we're not going to have this freedom of writing a positive number and meaning a negative number like the book says. We will keep the order, and we will always have the elasticity of demand as a negative number. This, we do it for two reasons. First, because I'm strange, strict, or you can say that because I want to do things in a correct way other than having this flexibility of giving them in whatever way. But there is a more important reason than that. The important reason is that if sometimes you get a positive elasticity of demand, this is something that should raise a red flag, like ping, something has gone wrong here. I have to recalculate that, I've made a mistake. So this alerts you in case that I expect a negative value and I'm getting a positive value. What the heck is happening? So it allows you to check yourself if you have done it correctly, and that's a more important reason, okay? Plus, the first reason is also true. Okay, so it will always be negative because of the law of demand. Now, this is a very important law. Let's have an example. Let's keep the formula. Let me throw everything else away, and let's take this and put it up there on the top. So we will keep looking at it when we calculate everything. So assume that price increases from 10 to 12, and quantity responds by decreasing from 50 to 45. All right, and I want to calculate my elasticity. All right, that's not difficult at all. Okay, you don't even have to look at the formula that much. You will do the percentage change in quantity. It decreases from 50 to 45. So it is the new minus the old divided by the old. Okay. The new quantity minus what it was before, the old, that's how I call it, divided by old. And this is something that I was doing since I was in your age, and I was doing it at school, at the 6th grade of high school that we did economics. That's how I remembered it, because very often I could confuse it. I would say new minus old over the old. Okay, that's my way learning it when I was a student many years ago. So this would be 45 minus 50 is minus 5 divided by 50 minus 0.1. Actually, you can see it, it's just 10%. So my quantity decreases 10%. Look at my sign here. I never forget my sign, because my sign shows me that this is a decrease. Okay, and I want to check in the end that my sign checks out. So then I will take my percentage change in price. I went from 10 to 12. That doesn't need a lot of thought. It's just a 20% increase. Okay, so again, the new minus the old over the old. 12 minus 10, 2 over 10, 0.2, 20%. So my elasticity will be delta Q over delta P over P. That's minus 0.1 over 0.2. This will give me negative 0.5, which means that my elasticity is minus a half. Now, to be honest with you, when this is an easy part, I do it mechanically pretty much. When I get here, because I usually also in research, we have some other elasticities that they're even more complicated than those ones. I always have to think, which one goes to the numerator again? Okay, so this is not like unnatural that you will have to think. Just make sure that you get it correctly, because getting the reverse will show you very different results, and we will see later how we can use those results to see what is going on in reality. Okay, so it's a good idea just to learn the formula to be able to know. You will have also a page of notes in the exam and test, and it would be a part of your notes to have the formulas there, so you make sure that you have what you take in the numerator, what you take in the denominator, because to be honest with you, I always forget, and sometimes I calculate the opposite thing, and then I'm like, this doesn't make sense, because I know what to expect. I know what kind of good has different elasticities from my experience in research, and then I'm like, oops, that's it. That's, again, I have taken the inverse here, and I have seen many other economists, Ph.D. economists, even like professors in top universities, messing up these formulas quite often. So it's a little bit a measurement that the measurement matters, but the way that you derive it is quite mechanic. Doesn't make any big difference. All right, in your intuition, but the result does make a big difference. Okay, so this is how we calculate an elasticity. This makes some goods to be what we call elastic, and some other goods to be inelastic. A good is elastic when the elasticity of demand is greater in absolute value than 1. In other words, the real elasticity of demand, not the absolute, is minus 1 point something, or minus 2, or more than that, like much more towards the negative than minus 1. So this means that the percentage change of quantity is greater than the percentage change in price. Okay, look at that a little more careful, because you will see that behind this truly nonsense doesn't really mean anything, delta Q's and delta P's and whatever. Okay, but if you look at that, you will see that this guy who has this elasticity for this particular good actually is very responsive to change in prices. When the percentage change in price is small, this person reacts a lot to quantity. It's like, what? Coca-Cola went up by 10 cents a can, no more Coca-Cola from now on. While somebody else could be like, Coca-Cola went up by 10 cents, who cares? I love Coca-Cola, I'm gonna keep drinking. All right, so this is the kind of response we are looking for here. So here we see that for this particular good, consumers in general, they respond a lot to changes in prices. A percentage increase in price will result to a larger percentage decrease in quantity. This is the kind of behavior that a small increase in price will decrease your quantity by a lot. This is the kind of good that you don't want to be a seller for. This is a bad good to be a seller for. This is a good that is good to be a consumer of that good. It's 3 times good in one sentence. Okay, you cannot beat that. All right, so a percentage increase in price will result into a larger percentage decrease in quantity. Let's say an example. If, for example, the elasticity is -2, it means that a 10% increase in price will result a 20% cut in quantity. Okay, you increase the price by 10%, you lose 20% of your sales. Okay, this cannot be good. This means it entails that an increase in price will cause your revenue to go down. So you're gonna be making less money if you increase your price from this good. If, for example, price increases from 10 to 11, that's a 10% increase, and quantity decreases from 5 to 4, that's a 20% decrease. Now, I'm consistent here, my 10% minus 2%, minus 20%, this is going to be on the numerator, this is denominator. I'm consistent with an elasticity of demand -2 that I showed you before. So this is an example consistent with an elasticity of -2. So if this happens, then revenue before the price increase, price was 10, quantity was 5, you had the revenue 5 times $10, $50. And then your revenue afterwards becomes, price went up to $11, but now the quantity went down to 4. So 11 times 4 gives you 44. So you increase the price, but your revenue went down. It was a bad move to increase the price in an elastic good. You should want to decrease the price in this case because this may increase your revenue overall. In the opposite side, we have the inelastic goods. If a good has an elasticity of demand that is closer to 0, the absolute value is smaller than 1, it means that delta Q over Q is smaller than delta P over P. It means that consumers do not respond very much to these kinds of changes of prices for this good. What kind of goods could be that? Like, for example, it could be something that you get addicted to, and you don't want to quit using it just because the price went up. Like, for example, we observe very low elasticities in cigarettes, in recreational drugs, in things that people tend to believe that they are they're quite useful for them, that they cannot do without them for one reason or for another. So if a good has an elasticity of demand that is smaller than 1, then a big change in price will cause a small change in quantity. Consumers will respond very little to the change in price. This means that if the elasticity of demand is the inverse of what we had before, instead of -2, now we have -1/2. This means that a 10% increase in price will result in loss of market share of 5%. The sales will go down only by 5%, less than what you increase the price in percentage terms. This means that an increase in price will cause your revenue to increase. Now for inelastic goods, you want to increase your price because this will help you increase your revenue. Let's see an example that is consistent with an elasticity of demand of minus 0.5. If price increases from 10 to 11, that's 10%, and quantity decreases from 5 to 4.75, that's minus 5% increase or 5% decrease. So this is consistent with an elasticity of demand of minus 0.5, and it will yield that the revenue before was, again, $10 times 5 units equals $50, and after the revenue was $11 times 4.75 units, this is equal to 52.25, which is greater than 50. So we see here that by increasing your price, you end up having more revenue. So if you're a seller, you want your good to be inelastic instead of elastic. You want your good to your consumers to not react to the prices, to the price changes that much. Elasticity is a measurement that is quite peculiar. First of all, and to end a misunderstanding that happens a lot, elasticity of demand is somehow related to the slope of the demand curve, but it is not the slope of the demand curve. The slope of the demand curve actually plays a role to elasticity. Those ones of you who understand calculus and derivative, you can actually see it with very simple calculus that they do have a relationship. Those ones that you don't understand calculus, you are not losing anything. You just have to understand that elasticity of demand and slope of demand, not the same thing. Okay, they are not the same thing. Let me show you something else. Elasticity is a point measurement. In other words, when you measure the elasticity, you measure it at a particular point of a demand curve, at a particular price, at a particular quantity. Okay, you do not measure it for the entire curve. So, elasticity of demand will be different even along any demand curve or almost any demand curve. I will show you a demand curve that the elasticity is constant. But for any other demand curves, then in this case, your elasticity of demand will be different at every point of this curve. All right, you will get a different elasticity of demand. All right, so here is an example. This is one of the simplest curves I could ever give you. It's a curve that has an intercept of 6. So elasticity from point A to point B. If you go from point A to point B, you decrease price by 20%, you increase quantity by 100%. So this means that your elasticity will be 100% over minus 20%, minus 5. So elasticity at A is minus 5. What is elasticity from point B to point C? If you want to go from point B to point C, you decrease price by 25%. You increase quantity now by 50%. Therefore, you will have your elasticity 50% over minus 25% equals minus 2. So elasticity at B is equal to minus 2. What is the elasticity from C going to D? You have to decrease your quantity to increase your quantity by 33.3%. You have to decrease your price by 33.3%. This will give you, dividing the two, minus 1. So this is the point that elasticity is equal to the slope of this line. But as you see, the other points do not have an elasticity minus 1. They have very, very different elasticity. Elasticity from D to E will be 25% over minus 50. That will give you minus a half. And then elasticity from E to F will give you 20% over minus 100%. This will be minus 0.2. So we see here that from every point, the elasticity of demand is different. And the elasticity of demand is actually relevant to the initial point. So you will see this in problem set 2 as well. If you go from point A to point B, the elasticity is -5. If you go from point A to point C, the elasticity will be again be -5, because what matters for the elasticity is the point where you begin from. Going from A to B is -5, going from B to any point will be -2, going from C to any point will be -1, etc., etc. Now, this is pretty much a slide that I made because a lot of students were confusing elasticity and slope, just to figure out that they are not the same. Now, I don't expect that anybody will look at the curve and will be just like that calculating elasticities. That's not the point. If you want to calculate the elasticity at point D, you have to do what I gave you here, like how much is the percentage decrease in price, how much is the percentage increase in quantity. It's a little calculative, it's a little technical, but you know how to do it. It's not that difficult, but I don't expect you that you're gonna do it just like that. Okay, so do not panic when you see calculations like this. You should know how to do it, but just you are not going to do it on the spot. It will take some time, and we understand that you will need some time in order to do that. Demand curves and elasticity. Let me give you some examples. This is a curve that in general, we refer to this demand curve, D1, as relatively inelastic. So this is an inelastic demand curve. Okay, why do we call it inelastic? Because it's too vertical. Okay, again, I say that the slope relates to the elasticity, but it's not. Here, we call this curve relatively inelastic. This curve here is totally inelastic. Okay, relatively inelastic and totally inelastic. It's like you say, do you like pizza? I totally like pizza. It's not an official term. This is like really inelastic. There is no doubt about that. This is like somehow inelastic, like relatively it's considered more towards the inelastic side than in the elastic side. So these are not official terms, is what kind of elasticity we expect in these curves. This curve here, D3, is what we call a relatively elastic curve. So this is more towards the elastic side than the inelastic side. So it's a curve that generally we call it its elastic demand. And then a totally elastic demand is this one. You are not going to find many demand curves like that, except one particular case that we are going to see in the next lecture. And then I promise to give you a really strange demand curve where elasticity is always constant, and this is the one. It's actually a hyperbolic demand curve. The elasticity remains constant at every point here because it's made such that the percentage change from one point to another will be always the same with what happens in the vertical axis in percent will be always the same with what happens in the horizontal axis. Now, how much does this matter for our class? I would say that not at all. And it's just something that satisfies our curiosity. If you have a little bit of a mathematical mind and you like those things, or else this was a 1 minute of your life that I took and you will never have back. All right, so a general picture about what to expect with demand curves, totally general, so you know in your eye what to expect. This gives you a little bit of experience. So from now on, you see a demand curve and you say, okay, this looks like it's kind of elastic, or if it's kind of inelastic. If it's exactly diagonal 45 degrees, then it's a demand curve that doesn't matter if it's elastic or inelastic, just matters that is negatively sloped, and that's all, because most of our curves, we are not gonna make a big deal if they are elastic or inelastic, but in some cases that the correspondence and the response of quantity to price matters, we will make use of elasticities much more at that point. Now, what matters, what determines if a good will have a high elasticity of demand or a low elasticity of demand? Okay, what makes a good elastic or inelastic? And this is going to be an interesting discussion. First of all, the availability of substitute goods, goods that they serve the same need. The more close substitutes you have, the stronger the substitution effect will be, which will decrease the slope of the demand curve. So in this case, as the number of available substitutes increases, the price elasticity of demand will increase too. Meaning that your good, if you're selling a good that doesn't have any substitutes, then consumers, want it or not, they will not react a lot to your price. Like your product will be kind of inelastic because consumers have only this choice. They cannot change it with something else. If, however, they can find substitutes, then in this case, they will switch your good with other goods that they remain cheaper relatively. And in this case, you will see a big response of quantity in changes of your price. All right, so the availability of substitutes affect the elasticity of demand. The second, the budget share that you spend on the good. The lower the expenditure of the good, the less the consumers will care for responding to changes in price. The smaller the share, the smaller will be the elasticity. The most useful example that we use when we're talking about the budget share spent on the good is salt. Salt is something that actually in general is really cheap. If you want to buy a whole month's supply of salt for an average household, this will be like 30 cents of a dollar for the entire month. If instead of 30 cents, this goes up, let's say, to 60 cents, you're not going to be like, oh, salt is 30 cents more expensive now per month. That's 1 cent per day. So that's a price that I'm not going to accept that. So from now on, I will not put salt in my food. No, you're not going to care. Who cares if paying like 1 cent more per day for salt? So changes in the price of salt will not have a big result in the consumption of salt just because households do not care because they consume too little salt in terms of how much money they spend on everything else. The budget share of salt is extremely small for somebody to care. So we have this result here that actually tells us that the elasticity of salt will actually be extremely small. Now, you may ask the question, so why doesn't the price of salt keep increasing in this case? The answer is something that we will start seeing from next time, competition. If you increase your price of salt and I don't, people will buy their salt from me. Okay, so competition keeps the price down, but in terms of elasticity, the elasticity is indeed very small, and we also have calculations to prove that. The third is a very interesting thing, is availability of time to adjust. Elasticity increases in the long run as it takes time for consumers to adjust their consumption habits or to find substitutes in some cases. And there are some very interesting examples that in this. Let me give you one example that makes very good illustration of how this works. In 2009, in my country, a big crisis started happening. It was a crisis that was initiated by the global financial crisis of 2007 that started in the United States and went to the entire world. And then because Greece was the weak link in the European Union, it actually led to a debt crisis that was huge. It lasted for many, many years. For some people, it's still, some economies, they still consider that it goes on in Greece. One of the results was that the government, because it had huge debts, started taxing everything really heavily, especially goods that consumers could not find substitutes to. At the same time, we had an oil crisis, and the price of oil started increasing for two reasons. One reason was the tax that Greece was imposing on local oil, on oil not that was produced in Greece. So the only oil we produce in Greece is olive oil. So it started, all the oil that was sold in Greece had the sales tax on it that was really, really important. I think it was something like 30% plus 50 cents of a euro on top of it. So we're talking about on a liter, you had maybe a dollar, something like $1 of a tax per liter of gasoline. And this was something that happened almost overnight. Now, for cars, this was not a big problem because people really cannot do without driving their cars. Some people, they started taking the public transportation. Some other people, they started walking from place to place. Nobody got a bicycle because they will kill you in Athens if you drive a bicycle, even a motorbike. And in this case, we had people that they didn't react that much when it comes to gasoline that was used for transportation. But there was another very important use of gasoline, and this was heating for residences. So in every apartment, in every house in Greece, there is a heating system because temperature in the winter will go down maybe in some cases 3, 4, 5 degrees. In some extreme cases, you can see even below freezing temperatures. So you do need to have heating almost in every house. Actually, in every house that is a decent house will have heating. And heating works mainly, used to work at least, mainly with petroleum. So you would order in the beginning of the year maybe 2 or 3 tons of petroleum. We had huge tanks in every house that you could store the petroleum there for the year, and then you will use it in heating water and transmitting the water upstairs to the different radiators that they will produce heat for the house. So this was a system that used to be very efficient. Oil was cheap, and with maybe 2,000 liters of oil per year, you could heat your home. And this was an expense that was around the amount of money that we pay here in Singapore for an average house for air conditioning, not more expensive than that. And everything was okay till the price increased almost overnight by €1. And from when paying, let's say, a couple of thousand of dollars per year for heating, you had to pay $4,000 per heating. Now, what happened? In the beginning, nothing. People said, so what am I going to do? I'm going to freeze to death just because oil is more expensive now. No, so they kept buying oil. So in the beginning, oil was taken to have very low elasticity, like to be a product that is quite inelastic. However, after a couple of years, this gave an incentive to engineers to start thinking about new solutions, gave an incentive to consumers to start being interested in those solutions. And today, 6 or 7 years after this particular situation started establishing, we had many, many houses, maybe the 70 or 75% of houses having abandoned directly, entirely the gasoline system of heating, and they now use alternative methods of heating. Most of them, they have to do with electric. Some other houses, they have wood-burning heaters. Some other, like they have a central furnace that burns wood. Some others, they burn another thing that is called a pellet, which I don't know what it is. Some other houses, they have a very different system that uses gas, natural gas, in order to heat the house. And all these methods actually made gasoline, made oil now to appear that is quite more elastic than it used to be 5 or 6 years ago. So you gave time to consumers till they adapted, and you gave time to technology till it will develop, and the elasticity was dynamic. It started from being very inelastic to some point being really elastic. The funny thing is that now with the crisis, some people that they were interested to change their old oil systems into the newer systems, to the heat pumps and to the electric heat pumps or the natural gas ones, they saw the price of gas going down like a lot to the negatives now, and people are like, what the heck is happening with this finally? Okay, but you can see here that elasticity can be also something that is dynamic. It changes from time to time. All right, so here's some estimates to just give you a little bit of experience of what the measurements are. Let's get started. Here we have the good and the price elasticity that scientists have estimated for this particular good. So for olive oil, the elasticity is quite high. It's quite elastic. This is because olive oil is a luxury good, at least outside of Greece, because in Greece, if you don't have olive oil, it means that you cannot cook. Like nobody can imagine cooking with any different oil than that. But in other countries, it's considered a luxury good. So if you, for example, it becomes very expensive, people will start using alternative oils, like, for example, this oil that is made from seeds, from sunflower seeds and stuff like that, which is much cheaper. And some people believe that is equally good. Peanut butter, minus 1.73. Again, it's quite elastic. Ketchup, minus 1.36. Wine, the elasticity of wine tends to be exactly 1, meaning that is not very elastic, not very inelastic. It's just on the limit there. Laundry detergent is quite inelastic, maybe because it's relatively cheap and people do not care that much. Shampoo, minus 0.79. Shampoo is not cheap, but shampoo has something else. If you believe, for some reason, judging from the advertisements of shampoo, a lot of people believe that this particular soap water makes you look prettier because it gives you shiny hair. Honestly, I never saw anybody ever that it will be dark and you will see a light and will be like, what is that? That's Maria's hair that is shining. Okay, never saw that. So if you believe that one particular shampoo gives you nice hair, then you stick to it and you don't react that much to changes in price. There is one form of consumer addiction a little bit in this kind of consumption. That's why it appears to be low. Potato chips. If you like them, they are not very expensive. Why should you care so much about the price? And cigarettes, minus 0.4. This is because we have seen in many examples, many cases, we have a very good estimate here for the elasticity of demand for cigarettes. And this is because cigarette is a very addicting product. I would say good, but it's not that good. So it's a very addictive product and people do not react to it. We have seen cases, especially recently, there was this tax in some Russian republics that they took prices of cigarettes that they were, let's say, $1 a packet, and they tripled them overnight. And we saw that people didn't react at all to changes in price. If you were smoking, now you're like, okay, I have to pay more for my cigarettes. If you were not smoking, again, you would not smoke. So the response of quantity to price was quite small just because of the addiction that is relative to this product. Now, cigarettes is a very good thing. I like cigarettes. Cigarettes are amazing. The only thing I don't like cigarettes is the chemotherapy that they come with after some time. Okay, so if some people, they don't understand that that's the real cost of smoking cigarettes and they are willing to risk getting cancer and dying just because they want to smoke cigarettes, how would you expect that the price will be what will stop them? Like, if it doesn't scare you the fact that you will die from smoking this thing, and it will stop you the $1 that you have to pay more per day, that could be quite an irrational way of thinking for making policy. So we see that people are quite unresponsive to prices just because not only they don't care about the price, they don't care about anything. Like cigarette companies, the tobacco companies have marketed the product in such an efficient and superb way that people are actually willing to die for consuming the particular product. And this is actually reflected to the elasticity here. All right, so this is what about the elasticity of demand. We have the cross-price elasticity, super interesting topic. And then we have the income elasticity also, another very interesting topic. But because I'm running out of lecture time, I have prepared video number 2 that talks about these two elasticities, explains what kind of product groups we have out of these two elasticities, the income elasticity and the cross-price elasticity, and it contains everything you need to know. It's on YouTube, you can go and watch it. If you have questions about today's lecture, please go ahead and write it down below in the comments. If you have any comment, any example, anything that you want to ask, please write it down in the comments. Do not send me email, not because you bother me, but because if you write it in the comments, everybody will see it and everybody will take advantage of your question. Also, if somebody asks a question, you are totally okay. You can go and answer this person's question. Okay, maybe your answer is wrong. Maybe it's arbitrary. Maybe it's anything. Go like somebody else's comments if you have the same question. Read the comment section after some time, that the comments have been written there, because it's very beneficial. We have done this last year and students got a lot of information from comments because comments actually give a kind of interaction, and this is the best we have under these particular circumstances. I would love it to have you all of you in here, and I will be able to interact with you and see your faces when I say something hard, so I can slow down and see your faces when you get bored, so I can pick up or make it a little more interesting or anything like that. But we cannot do that, and the best thing that we have right now is the comments, and they can work pretty constructively. So use them, write your comments. I will go there and I will answer the comments. I will also go and like your comments or love them, or any other of interaction is very welcome, and I expect you to do that. Also, if you have any comments about the production, about the sound, about how you can see things, anything you want to comment, you feel free to go ahead and write everything that you want. Also, a nice trick, that's a kind of late that I'm saying that, a nice trick is that you go and change the speed of the lecture. Sometimes the speed of the video, so I heard students saying, okay, when I get bored and I think that I understand what you're saying and I think you're going too slow, I put it to 1.5 speed, and you go like that. And then if I see that I cannot catch up with you, then I pause, I go back, I rewatch it, and it always helps to keep notes. So this is what we had to say for today. I hope that you will make use of the comments, and I will see you for lecture 3 next week.